What is thermodynamics? Importance of thermodynamics. Application of thermodynamics. Laws of thermodynamics. Kinetic theory of gases. Heat and temperature. Hi, hello everyone. Warm welcome to our YouTube channel. Let us know about thermodynamics. Thermodynamics is the study of the relationship between heat, work, temperature, and energy. The system can be perform useful work on its surroundings. Usage of thermodynamics. Photosynthesis, combustion, throwing a ball, heat engines. Importance of thermodynamics. The thermodynamics is important. It helps us to understand how energy is transferred and used can be applied to many aspects of our lives, including designing building and developing new energy sources, alternative energy sources. Reduced pollution. The thermodynamics helps design systems that minimize waste and emission. Improved understanding of molecular system. Thermodynamics help us to understand potential of molecule network and the details of the design. Applications of thermodynamics. Thermodynamics has many applications in engineering, biology and everyday life. Few applications of thermodynamics. Engineering, biology, everyday life. About engineering. Mechanical engineering. Thermodynamics is used to design engines, power plants, air conditioners, and refrigerator systems. Power plants. Thermodynamics is used to design and operate steam turbine in thermal power plants. HVAC system. Thermodynamics is used to design heating, ventilation, and air conditioning system. About biology. Photosynthesis. Plants uses thermodynamics to convert light energy and water into chemical energy. Usage of daily life thermodynamics. Melting ice cubes. Thermodynamics explains how ice cubes absorb heat from a drink, make it cooler. About heat engines. Thermodynamics explain how heat engine converts heat energy into mechanical energy. About laws of thermodynamics. There are three laws of thermodynamics. About first law of thermodynamics. Energy can't be created or destroyed, but it can be transferred between systems. This law is also known as the laws of conservation of energy. Example of first law of thermodynamics. Photosynthesis. Light energy converts to chemical energy. A ball falling from a height. Potential energy converts into kinetic energy. About second law of thermodynamics. Gradual increase over time in a closed system. Heat will flow from a warm object to a cooler object until they observe reach the same temperature. Example of second law of thermodynamics. A car engine converting heat from burning fuel into work. About third law of thermodynamics. Entropy approaches zero as temperature approaches absolute zero. When a bullet is fired from a gun, the gun extracts a force on the bullet in forward direction are equal to backward direction gun. About kinetic theory of gases. The kinetic theory describes a gas as a large number of submicroscopic particle atom or molecule, all of which are in constant and random motion. About pressure. The pressure of gas is caused by the collision of molecules with the wall of a container. About temperature. The average kinetic energy of the molecule is proportional to the temperature of gas. Example for temperature. Kinetic energy is directly proportional to temperature. About volume. The volume of a gas is determined by the number of molecules and their velocities. Reason for volume. The volume is directly proportional to the kinetic energy divided by the pressure. About viscosity. The viscosity of a gas is a transport property that the kinetic theory of gas can explain. Example for viscosity. Molecular motion, intermolecular motion, momentum transfer. About thermal conductivity. The thermal conductivity of a gas is a transport property that the kinetic theory of gas can explain. Example for thermal conductivity. Molecular movement, average kinetic energy, material dependence, high thermal conductivity, low thermal conductivity. Mass diffusivity. The mass diffusivity of a gas is a transport property that kinetic theory of gas can explain. A particle of a substance moved from a region of higher concentration level to lower concentration level due to their randomness, constant motion, and inherent kinetic energy. The relationship between heat and temperature. In thermodynamics, heat and temperature are related concepts. Heat is the transfer of thermal energy between objects while temperature is the average kinetic energy of the molecules in substance. Use of heat, solar energy, industrial process, medical applications. Usage of temperature, scientific research, weather forecasting, controlling industrial process, monitoring the body.